So you don't come up with things like, well, I got in the craft, 5 minutes went by, I came out, and 2 hours had gone by. I mean, you're just not going to make that up. Then on the right-hand side of the piece of paper, I said, okay, we have Einstein's equations in general relativity, and we use them to talk about black hole mergers or neutron star mergers or whatever. And all these things are massively energetic events. Suppose I could engineer Einstein's equations the way we engineer Maxwell's equations for electromagnetic effects. What would I expect to see? And I find out I got a hand-in-glove match between what was claiming to be observed and, what Einstein's equation, if you could engineer them. Well, why can't we engineer them? Well, what we know today is the energy density required to engineer those equations is just way beyond our ability to do so. So,
can you give me a comparison to what the energy requirements or something like that would be like?
Yeah, people have in fact Alcubierre warp drive. I don't know if you've heard of that, but Miguel Alcubierre was a researcher in general relativity and kind of a Star Trek fan and so on. He said, I wonder if we could really have warp drive. And so he used Einstein's equations to say, okay, under what conditions could we do a warp drive? And he actually came up with solutions from out of the equations. Okay, what would it take to drive that? Oh, it would be hundreds of times more than the energy of the sun. I mean,
wow.
Just out of sight energy. So, until we have a new energy source, or until there's some back door that we haven't, zeroed in on, it's just really outside of our expertise.